All right, so now that we've learned about how to calculate the molar mass of a substance, it's very important that we get into further defining the mole. Now, we've talked in class about how 1 mole is equal to exactly 6.02 times 10 to the 23rd particles of that substance. Now, if we are talking about an element, those particles are the particles, the fundamental particles we call them, that make up elements, or in this case, atoms. Now, if we're talking about a compound, those particles could be either molecules, in the case of molecular compounds, or formula units, in the case of ionic compounds. Either way, when we're talking about particles in 1 mole of a substance, we're talking about exactly that number of particles, 6.02 times 10 to the 23rd. And as you'll remember, that number is known as Avogadro's number. So Avogadro's number is one of those things that you're really just going to have to know. But a lot of students that we've seen in the past have overused Avogadro's number, so you also have to be careful for that. The only time you will need to use Avogadro's number when doing calculations based on the mole are when we ask you something about particles, when we ask you how many atoms of something are in a certain number of moles, or when we ask you to determine the number of moles in a certain number of molecules of a substance. So, let's look at an example. I'm going to give you an example just off the top of my head, and I'm going to ask you to find out how many atoms are in 2.25 moles of, let's say, oxygen. So now we're just talking about elemental oxygen, just single oxygen atoms. You will remember that oxygen is usually written as O2, but in this case I just want to know how many oxygen atoms we have in 2.25 moles of elemental oxygen, straight up O. So, you'll remember that the way to handle most of these problems, or the most effective way really, is by dimensional analysis. That is how we want you to do these problems as well. So let's make sure we set up a grid. Before we do set up a grid, though, we want to write down everything we know about the problem, and everything we might need to know to solve it, all the necessary conversion factors. So, here's what we're going to do. We're going to write down what we know about the relationship between moles and atoms, namely, that 1 mole contains Avogadro's number, or 6.02 times 10 to the 23rd atoms of oxygen. Now, if you look at it, that should be the only thing we need to know. This is just a one-step problem. All we need to do is go from moles to particles. So, here goes nothing. I'm going to start out with what we know. In any dimensional analysis problem, you always want to start out with what you know. So, 2.25 moles of oxygen, and I'm abbreviating that MOL, which is perfectly acceptable. And I'm going to set up a grid. Now, in dimensional analysis, you always have to make sure you cancel out the units you don't want and retain the units that you do want. Now, in this case, we're trying to solve for atoms, so that's what we want to end up with. Obviously, we want to cancel anything that's not atoms, so we want to cancel moles. Now, we know, because we just wrote it up above, that 1 mole of oxygen is equal to 6.02 times 10 to the 23rd atoms of oxygen. So now that we know that information, we should check to make sure that we have the units we want. And in this case, we do. We want atoms, because that's what we were asked about, and we have atoms right here. So, all we need to do now is crunch the numbers. Now, if you need a refresher on how to enter exponents into your calculator, we can talk in class. But I'm going to assume that you remember that from the beginning of the year, and we're going to talk about how to solve this. So first, we're going to punch in 2.25 moles. Anything that's on the top, we multiply. So I'm going to multiply by 6.02 times 10 to the 23rd. And then I'm going to divide by 1, which basically keeps that number the same way it is. Since we started out with 3 significant figures here, our answer should also be rounded to 3 sig figs. And so what you get in the end is 1.35 times 10 to the 24th. And in this case, the unit, which is always important, becomes atoms. Anytime you need to convert between moles and atoms, in either direction, the conversion factor you're always going to use is Avogadro's number. So, hopefully that gave you a little refresher on how to convert between moles and particles, and I hope you enjoyed it. Thanks for watching.